Ah, those lazy dog days. You know, sometimes I wish my life was like this. Yeah, but then you wake up and you realize you've got a stats project to do. This is my dog Titan. I am Sarah St. Pierre, the anonymous stats person. And this is our 5-minute statistics break. So now, the reason I'm putting Titan in the video is because we decided to do a little experiment on neutering, which is very applicable to Titan since, of course, he is neutered. Hey, puppy, give me a face. He's been a little pooped. We've gone through a few takes already, so all fattened up from the cookies. But back to business. Yes, Titan, back to business. Alright, so I've got our data on the computer. Me and Titan did a little fake experiment to see if weight gain was an issue with neutering. So, to put it in better terms, were dogs who got neutered more likely to gain weight? So, we have 3 categories: weight gain, weight loss, and no weight change after surgery. Now, it's hard to see the numbers on the computer, so I'll write them down. The numbers that gained weight were 29. The number of dogs that lost weight was 13. And the number of dogs that had no weight gain whatsoever was 15. So that brings us to a total of 57. So 57 dogs total. That's gain, loss, and no change. Alrighty. So the best way to figure out if these results were significant is to use the chi-square test. There are 2 kinds. There is the one-way classification and the 2-way classification, or as they're better known, the goodness of fit and the contingency table analysis. Titan! Hello! Alright, back to work. So, because we don't have any expected values with us, we only have our observed, we are going to use the goodness of fit to see if our results were better than chance. So, to figure out the goodness of fit, I need to have an expected frequency. To figure this out, I'm going to divide the total number of dogs by the number of categories, 3. So 57 divided by 3 comes up to 19. So the expected frequency for all 3 categories will be 19. So observed and expected. There we go. Alrighty. So the reason we have 19 is because that levels the playing field. So now we can see if our results would be better than chance. So to do this, we want to use our formula. Chi-squared equals, brackets, the observed frequency, which was that, minus the expected frequency, the 19, squared, divided by expected frequency. I think someone's longing to go outside. Don't worry, we'll be done soon. Alrighty. Oh, we don't want to forget this sum. Because at the end, we're going to do this calculation for each of the values, and then we're going to add them all together. So now, by doing that, just make it quick. We'll get the results from my computer. For the weight gain, the value was 5.263158. For the loss, it was 1.894737. And for no change at all, it was 0.8420105. Now that total gives us a very even number of 8. But what does this mean to us? Well, Titan, I'm sure you don't understand, but I'll explain it to everybody else. So we have to figure out if this is a significant chi value. By doing that, we want to go to a table in our little booklet. This is a smaller version, but we can still work from it. So we want to figure out if our numbers are in the upper distribution of the scale. In other words, are they better than chance? Are they outside the normal distribution? So usually in statistics, we go with 0.05%. So we want to be in the upper 5% margin. Now, to figure out the value, the critical value, we need to have degrees of freedom. Degrees of freedom in a goodness of fit model is the number of observations minus 1. So in our case, we have 1, 2, 3 observations. Minus 1 gives us 2 degrees of freedom. So 2 degrees of freedom. So now we got to look at our table for the upper percentage points of the chi distribution. Now if we look at degrees of freedom of 2 with 0.05%, our critical value is 5.99. Alrighty, so our number, our chi value was 8, and the critical value is 5.99. So what does this mean for us? Well, it means that since it's higher, we can say that our results were better than chance. In other words, dogs who are neutered are more likely to gain weight, at least in this experiment. Now, we can conclude our results in saying it's probably because hormone changes in the surgery, possibly getting less exercise after the surgery. Who knows? That's not important to us in statistics. That's somebody else's job to figure out. But all we know is that our results are significant, and we can reject the null hypothesis. So we know that these results are unusual and probably aren't the result of just random numbers. So it's more likely to happen, less likely to happen if it was chance. So in other words, dogs who are neutered usually gain weight. As we can tell, 29 of the dogs in our experiment gained weight. Now, those are my results on the computer. Basically the same thing, just a little cleaner. But since it's hard to see on the camera, we decided to do it like a live demonstration, just like in class. Alrighty then, so that's all for now. Thanks for watching. Sorry for the poor quality of video, but I don't own any fancy digital camcorders, so I have to make do with my digital camera. But anyways, Titan was very happy to be answering his question, even though probably he gained weight after getting neutered too. Titan! But there's a lovely shot for you. And thank you for watching. This is our little 5-minute stats break, signing off. And thank you very much for watching. And have a great afternoon, evening, or morning, whenever you decide to watch this video. Bye!